Hello, Mr. Collier here. This is the final video in the Lab 6b Newton's Third Law series, and in this video I'm going to talk to you about the calculations and analysis for this lab. So in Lab 6b, you set up the flat track with the photo gates 15 centimeters apart. You linked two cars together with a rubber band around one car, and then you removed that link and the two cars sprang apart with equal and opposite force. We manipulated then the mass of each car to see how that equal and opposite force acts on different masses. You set up 4 different trials to test different combinations of mass in the two cars. The one thing that was always in common, though, was that the forces were equal and opposite, because the rubber band pushed off both cars equally. In combinations when the mass was equal, we observed that the equal and opposite force created equal and opposite acceleration. However, in other trials, when the mass was not equal, you found that while the force was equal and opposite, the acceleration was not. And that's Newton's second law in play there. On your data table, you recorded the time through the photo gate for each combination. And real quick, I'm going to show you how to do those calculations. So this is the data from the trials that we did in part 2 of this video series. We found that it was 0.0333 seconds through photo gate A, and 0.0677 through photo gate B. Our calculations are going to be done just like they've always been for the speed across a single photo gate, 1 centimeter, which is the width of the flag, divided by the time. So for example, 1 centimeter divided by 0.0333 comes out to 30.0 centimeters per second, and that's 3 significant digits. While the speed across B, 1 centimeter divided by 0.0677 comes out to 14.8. And you'll notice that the car with half the mass, 0 marbles, had twice the speed of the car with double the mass. So, greater mass is linked to slower speed, less mass to higher speed. And that goes back to Newton's second law, force equals mass times acceleration. So what you're going to see as well is that when the masses are equal, your speeds should be just about equal. While when your masses are very different, you get very different accelerations, and therefore very different speeds. And that's Newton's third law at play. The forces are always equal and opposite, but we're also seeing Newton's second law at play. When the masses are different, the effect of that force is different. Good luck.